Okay, this is the 2-3 solving absolute value inequalities. I just want to refresh our memory. From 2-2's notes, we had a chart that showed us what our graphs would look like when we had x is equal to a, x is less than or equal to a, or x is greater than a. So again, if x is less than a, that means that we're going to have between a and negative a, whatever those answers are, and our shading would be between those. So whenever absolute value is x is less than a, like it is here on this side, then it's going to be x is greater than negative a and x is less than positive a, which is going to cause them to shade between them. If x is greater than a, like it is on this side, then you'll end up with x is less than negative a and x is greater than a, which means you're going to shade away. So now that we've reminded that, let's look at solving absolute value inequalities. This isn't really all that different than solving the other ones. The only thing that's different is, in addition to changing making the second side negative, we're also going to flip our sign. So if it starts as less than or equal to, we're going to have a greater than or equal to when we change the sign to negative. Other than that, it is exactly the same work. You still solve for x, but then when we do our final picture, instead of just putting dots, we're going to shade in the direction it's showing. 4 is shading towards the x, so we're going to shade from 4 backwards. And negative 4/3, x is shading towards the x, so it's going to go this direction. So that's why you would end up shading between it, okay? So let's do another example. Again, our first check is there any numbers adding or multiplying times our absolute value? There is not, so we can go ahead and separate. So we're going to do 7 minus x is less than or equal to 3. 7 minus x is greater than or equal to negative 3. Because we changed it to a negative, we have to flip our sign. Other than that, it's just solve for x. We're going to take and subtract our 7. We bring down our negative x, and that gives us negative 7, which is negative 4. Now we have a negative in front of the x. To get rid of that, we have to multiply both sides by negative 1. Anytime you multiply by a negative, you're going to flip your sign back over. So in this case, we're flipping it that direction to the other side, changing this to a negative 1, or positive 4. Now we're going to do the same thing over here. So negative x, and that's negative 10. Now again, to get rid of the negative, we multiply by negative 1. And again, we flip our sign again. So we flipped it initially just so we could separate them. Now we flip them on this step because we were multiplying by a negative 1. Okay? So what is this showing me? I'm showing x is going to be pointing, let me put my 4 and my 10. Okay, so x is everything bigger than 4. So I am starting at 4 and I'm shading in that direction. I'm starting at 10 and I'm shading in this direction. So that's shading between. Sometimes if you draw yourself a little, I'm trying to understand, what does this really mean? Well, that means x is bigger than 4. What are bigger than 4? Well, 5 is bigger than 4. I'm going to shade towards 5. What is less than 10? 9 is less than 10, so I'm going to shade away. And they shade only between the two. Okay, one more example. Here is another one where we have to get all of the things away from the absolute value. So before we can even start, we have to take and rearrange our equation so that we do not have anything in front of or being added to that absolute value. Opposite of 1/4 is multiplying by 4. So we're going to multiply by 4 on both sides. That gets rid of that, and that leaves x, absolute value of x, less than negative 4. Now we can separate. Now we can do our x minus 3 less than negative 4, x minus 3 greater than positive 4. See, it was negative originally. We want to keep the original sign, and then we do the opposite on the other side, as well as flipping the sign. Now we solve. X is less than negative 1, and we do it one more time. X is greater than 7. So we're going to put 7 and open hole because it is not equal to, and negative 1. And we're going to shade -1 less than going that direction, and 7 greater than going in this direction. So we're going to shade towards, away from each other. So away from each other. Okay, so I'll let you do number 14. Again, just follow the steps. It's really not that difficult to do this. Now, without solving, how do we know what our answer is going to look like? Well, we know it based on the template. The template says, from what we started with, when x is greater than or equal to a, then the answer, we'll get two answers, but they will be shading away from each other. We call that disjointing. So that's what it would look like. So even though we don't know what x actually is, we can tell what our graph should look like. Okay, couple of real world problems. Oh, I'm sorry. If we want to write absolute value statements, so like you have a problem and it's asking you to write the statement, and it tells you your x is between this. This is where they've already done the work, so they've solved it, and we're working our way backwards. So the first thing we have to do is figure out what is the average amount of, what is the distance across, the average between the two. So we add them together and divide by 2, it tells us the average. Then we figure out the distance away from 0, which is finding the distance between the two, and divide it by 2. And then our answer is in the form of x minus the mean is less than or equal to the deviation. So when we're doing some word problems on this assignment, that is going to be your basic formula. X minus the mean is less than or equal to or greater than or equal to, depending on what the sign is in the original question, to deviation. So let's try one more example. We're going to add the two numbers together and divide by 2. That will tell us our mean. So that's 370 divided by 2. Real quick, grabbing a calculator. Which is 185. So that's our mean. And then we do 230 minus 140 divided by 2, which is 90 divided by 2, which is 45. And that's our deviation. And then we just stick it into the formula setup. X minus my mean, which is 185. And then it's less than or equal to, because that's what the signs were originally, 45. And that's it. So I'm going to let you do the last two. They're the same type of problem. They're just using the formula. This one is going to be a little bit more tricky because you have the two directional. But if you go back to your original two directional, your formula is x is greater than or equal to, in this case, a. So that kind of gives you an idea. Okay, so it's actually absolute minus mean greater than or equal to deviation. So same kind of concept, that's going to be the distance. Okay, last example is a real world problem. This is similar to one that you actually do have on your assignment. So meteorologists predicted the 4th of July temperature would be 4 degrees within, the word within tells you your deviation of, that tells you your mean. So again, we're going back to that same formula, difference, or D being the degrees, they're just saying that instead of x, minus the mean is less than or equal to the deviation. But what does it actually mean in the real world? Well, 92 would be the middle temperature, and it's either going to be 4 degrees less or 4 degrees more. Okay, so I'm going to let you do number 8 on your own.